Hello friends, welcome to my YouTube channel. Today we're going to prove that modulus of its characteristic root of a unitary matrix is unity. Okay, so what we are going to prove? We are going to prove that modulus of its characteristic root of unitary matrix is unity. Now you see, before I prove this, let me tell you a few things. Let me tell you what is unitary matrix, okay, what is identity matrix, and transpose conjugate, those kind of things. Then I'm gonna show you how to prove this. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you, and help me to grow my channel. Right, and if you want to follow me on Insta, this is my Insta ID, Oza Likhajit, LAKHYAJIT123. This is my Insta ID, so you can follow me on Insta if you want to follow me. So now let's start. First, let me tell you what is unitary matrix. Suppose we have a square matrix. Suppose A is said to be unitary matrix. Unitary matrix if product of A and its transpose conjugate. Hope you know this, a theta on A. That means transpose conjugate means so conjugate of A and its transpose. Okay, so that is transpose conjugate, and their product is, suppose their product gives identity matrix. So hope you know identity matrix. Identity matrix is a square matrix whose diagonal elements are 1 1 1 and remaining elements are 0 0 0. Right, this is identity matrix. Hope you know these things. Okay, and to prove this, what we want to prove, that modulus of its characteristics root of unitary matrix is unity. Let me tell you one more thing. Suppose lambda is a characteristic root of A, or you can say eigenvalue of A, then there exists such matrix, suppose X, such that AX is equal to lambda X. So you must know these things, right? So now let's prove this. Okay, proof. So what we are going to prove, that modulus of characteristics root of a unitary matrix is unity. Okay, so let me show that how to prove this one. So first, what we're gonna do, so we're gonna consider a unitary matrix. Suppose A is a unitary matrix, right? Then according to the definition of unitary matrix, then transpose conjugate of A into A, that must give an identity matrix, that is I. So let me take this as equation number 1, suppose. Then let lambda be a characteristics root of A, suppose. Okay, so that XA or AX is equal to lambda X. So this is suppose equation number 2. This is suppose equation number 2. Let me take this as equation number 2. Right, now taking conjugate transpose of both sides, taking conjugate transpose of both sides, so if you don't know the conjugate transpose of both sides, conjugate transpose of a matrix, then what's the video, that link is in the description box. Okay, so now you see, if we take the conjugate transpose, then ax a to the power theta is equal to lambda bar x this. As it is a characteristics root, that means it is not a matrix, it may be a complex number or it may be a real number, so that's why or it may be an imaginary number, so we can take the complex conjugate of this only, not the transpose. Transpose is applicable in case of matrix only, right? So that's why I have written here this bar represents conjugate, right? So hope you have understood this. So now we can write transpose conjugate of A into transpose conjugate of X, conjugate of lambda is transpose into transpose conjugate of X, right? Now let me take this as equation number 3, suppose. Let me take this as equation number 3. Now what if we multiply 2 and 3? Let's multiply 2 and 3. Let me copy these two equations and let me go to a new slide. Let me take a new slide. Just let me copy this, and here is the new slide. This is equation number 3, and let me write equation number 2 as well. This is equation number 2. Okay, so here is the equation number 2. So if we multiply 2 and 3, then what we're gonna have, so here we're gonna have this a complex conjugate conjugate transpose of A, conjugate transpose of theta into Ax is equal to then conjugate lambda into conjugate transpose of X into lambda X. That's what we're gonna have, right? If we simplify this, A conjugate transpose of A into A and conjugate transpose of X into X, right? We're gonna get this. On the other side, we're gonna get lambda conjugate of lambda into lambda and conjugate transpose of X into X. That's what we're gonna have, right? Now you see, as I have already told you, so since A is a unitary matrix, in case of unitary matrix, product of if you multiply conjugate transpose of A with A, then it must give an identity matrix. So in equation number 1 I have mentioned, so from 1 I'm going to put here I. Okay, so that is identity matrix. Conjugate transpose of X into X is equal to conjugate lambda into lambda, conjugate transpose of X into X. So using equation number 1, that's what we have got, right? So now you see, if you multiply any matrix with the identity matrix, then you're gonna get the same matrix, X into I, that's gonna give you again X. So that's why we can consider this as this way, that you can write this way. Just wait, you can write the identity matrix here, and these two, product of these two, that's gonna be again X. So that's why conjugate transpose of X into X. So here we are getting lambda, conjugate lambda into lambda, and conjugate transpose of X into X. So now transfer this one to other side, then what you're gonna get, then you can take common as well. If you take common, then you're gonna get this, right? So this is brought to this side, then minus, then this part is taken common. So hope you have understood this, right? Is equal to 0. So if that is the case, now you see this conjugate transpose of X and X are not equal to 0, remember that. So here the only possible thing that can be 0 is conjugate of lambda, therefore conjugate of lambda into lambda minus 1 is equal to 0, right? So conjugate of lambda into lambda, that's nothing but square of mod of lambda, and on the other side minus 1 becomes plus. So this implies mod of lambda is equal to 1, which is proved. Okay, so that is what we needed to prove. Modulus of characteristic root of a unitary matrix is unit, that means 1. Hope you have understood this. Thank you for watching. See you in the next video.